An AI agent is a system that uses a large language model to dynamically decide the actions that are needed to accomplish a goal. Unlike a traditional application that follows a fixed sequence of steps, an AI agent continuously reasons about its current state, information that is available, and the objective that it is trying to achieve before deciding the next step. AI agents use large language model for both content generation and also as a reasoning engine. AI agents are goal oriented and they typically operate in an iterative observe, plan, act, and evaluate loop to achieve the goal. By continuously assessing the progress for deciding the next steps, agents can adapt their approach, and this makes them well suited for open ended tasks and complex decision making problems that are hard to code using traditional methods. The process begins when agent receives a goal or task to accomplish. Agent maintains execution memory, which is called state, and the goal is added to the state. As an initial step, the system may retrieve relevant context from enterprise knowledge sources such as databases or vector stores and add this context to the state. The current state, along with information about the tools that are available for solving the task, are sent to the large language model. Tools can include APIs, external systems, retrieval functions, or any endpoint that can be invoked to do some action. Model observes the input and reasons about the next action. It may generate a plan, decide to invoke a specific tool, request additional information, or produce the final response if it has all the information. It is important to note that while model determines which action should be taken, it is the surrounding agent system that is responsible for executing the action, such as calling the tool or retrieving the data. The result of each action is added to the agent's state and it becomes part of the context for subsequent reasoning. The model evaluates the result of the execution cycle and determines if it has achieved the goal or there is more work to be done, in which case it repeats the cycle. Now that we have seen how an agent operates, let us learn about the key characteristics that distinguish an AI agent from traditional AI application. The first characteristic is that agents are goal oriented. Unlike a chatbot whose job is to simply answer the next question, AI agent is working towards completing an objective. Every decision that it makes is evaluated against that end goal. The second characteristic is that agents make decisions dynamically. Instead of following a predefined logic which is written by developers at design time, the large language model reasons about the current state, available context, and desired outcome to determine the next action. Modern enterprise agents don't rely only on the knowledge inside the model. They decide when to invoke APIs, search knowledge bases, execute workflows, or interact with business systems. Another defining characteristic of agents is that they create a plan for breaking down the complex objectives into smaller tasks, and as information becomes available, they revise this plan and continue towards the goal. Agents also maintain a state which is their execution memory. It contains goal, retrieved context, intermediate results, previous tool outputs, and everything that agent has learned while working on the current task. Agents react to outcomes. Instead of blindly continuing with the first plan that they create, they evaluate the results of different actions and adjust their behavior accordingly. If a tool fails or information is incomplete or previous assumption turns out to be incorrect, the agent doesn't simply stop. It can rethink the problem, choose a different tool, gather more information, and continue working towards the objective. Now, let us look at the key components of an AI agent. At its core is the large language model, which provides reasoning and decision making capabilities. Agents maintain prompts and prompt templates for LLM instructions. Agents connect with enterprise knowledge sources such as databases, vector stores, and document stores for retrieving context for the current task. They take action through internal and external tools such as APIs, functions, and services. Agents maintain both in process state and long term memory. The state contains information which is needed during the current execution, such as the conversation history, retrieved context, intermediate results, etc. This information is shared across agents' reasoning and execution steps for the current problem. Agents can persist the state checkpoints to resume execution in case of failures. They also maintain long term memory of user interactions in persistent storage. This memory could be a summary of the conversation, users' preferences, or any facts that are learned so that agents' performance can be improved over time. Since agents' execution is non deterministic, it is important to implement security and reliability guardrails for enforcing policies, validating inputs and outputs, and constraining agents' actions. For critical tasks, agents can incorporate a human in the loop for approvals and for getting feedback. Although we have been discussing the dynamic planning and execution cycles of agents, most production grade agents follow a hybrid architecture. They combine predetermined workflow steps with dynamic LLM driven reasoning to combine the agent's flexibility with workflow reliability. And therefore, agents also contain workflows, especially in complex business processes. Now that we know what agents are, the next question in your mind could be, how do I build an agent? There are numerous frameworks and tools that are available today for building AI agents, and what you see on the screen is a subset of such tools. LangGraph, which is an orchestration agent, is becoming particularly popular for creating reliable and stateful agent workflows, while platforms like Langsmith are popular for observability. The ecosystem is evolving rapidly, but a practical stack for many organizations today is to use a large language platform such as Amazon Bedrock or OpenAI that provide state of the art frontier models. LangGraph can be used for agent orchestration. Vector databases such as Pinecone or pgvector can be used for retrieval. Enterprise APIs are typically the tools that are invoked by the AI agent, and Langsmith is a good choice for observability.